Welcome to ADV03 Data Mining, Topic 2. There are many more challenges in data mining in addition to the problems above mentioned. More problems are disclosed as the actual data mining process begins, and the success of data mining relies on getting rid of these difficulties. Data mining techniques. These tools can incorporate statistical models, machine learning techniques, and mathematical algorithms such as neural networks or decision trees. Thus, data mining incorporates analysis and prediction. Depending on various methods and technologies, from the intersection of machine learning, database management, and statistics, professionals in data mining have devoted their careers to better understanding how to process and make conclusions from the huge amount of data. But what are the methods they use to make it happen? In recent data mining projects, various major data mining techniques have been developed and used, including association, classification, clustering, prediction, sequential patterns, and regression. Classification. This technique is used to obtain important and relevant information about data and metadata. This data mining technique helps to classify data in different classes. Data mining techniques can be classified by different criteria as follows. We have classification of data mining frameworks as per the type of data sources mined. This classification is as per the type of data handled. For example, multimedia, spatial data, text data, time series data, World Wide Web, and so on. Next, we have classification of data mining frameworks as per the database involved. This classification based on the data model involved. For example, we have object-oriented database, transactional database, relational database, and so on. Next, we have classification of data mining frameworks as per the kind of knowledge discovered. This classification depends on the types of knowledge discovered or data mining functionalities. For example, discrimination, classification, clustering, characterization, etc. Some frameworks tend to be extensive frameworks offering a few data mining functionalities together. Next, we also have classification of data mining frameworks according to data mining techniques used. This classification is as per the data analysis approach utilized, such as neural networks, machine learning, genetic algorithms, visualization, statistics, data warehouse oriented, or database oriented. The classification can also take into account the level of user interaction involved in the data mining procedure, such as query-driven systems, autonomous systems, or interactive exploratory systems. Clustering. It models data by its clusters. Data modeling puts clustering from a historical point of view rooted in statistics, mathematics, and numerical analysis. From a machine learning point of view, clusters relate to hidden patterns. The search for clusters is unsupervised learning, and the subsequent framework represents a data concept. From a practical point of view, clustering plays an extraordinary job in data mining applications. For example, scientific data exploration, text mining, information retrieval, spatial database applications, CRM, web analysis, computational biology, medical diagnostics, and much more. In other words, we can say that clustering analysis is a data mining technique to identify similar data. This technique helps to recognize the differences and similarities between the data. Clustering is very similar to the classification, but it involves grouping chunks of data together based on their similarities. Regression. It is used to define the probability of the specific variable. Regression, primarily a form of planning and modeling. For example, we might use it to project certain costs depending on other factors such as availability, consumer demand, and of course, competition. Primarily, it gives the exact relationship between two or more variables in the given data set. Association rules. Association rules are if-then statements that support to show the probability of interactions between data items within large data sets in different types of databases. Association rule mining has several applications and is commonly used to help sales correlations in data or medical data sets. The way the algorithm works is that you have various data. So for example, a list of grocery items that you have been buying for the last 6 months. It calculates a percentage of items being purchased together. Outer detection. This technique may be used in various domains like intrusion, detection, fraud detection, and others. It is also known as outlier analysis or outlier mining. The outlier is a data point that diverges too much from the rest of the dataset. The majority of the real-world datasets have an outlier. Outlier detection plays a significant role in the data mining field. Outlier detection is valuable in numerous fields like network interruption identification, credit or debit card fraud detection, detecting outlying in wireless sensor network data, and others. Sequential patterns. It comprises of finding interesting subsequences in a set of sequences, where the stake of a sequence can be measured in terms of different criteria like length, occurrence, frequency. In other words, this technique of data mining helps to discover or recognize similar patterns in transaction data over some time. Prediction. It analyzes past events or instances in the right sequence to predict a future event. Data mining implementation process. Data mining techniques must be reliable, repeatable by company individuals with little or no knowledge of the data mining context. As a result, a cross-industry standard process for data mining, or CRISP-DM, was first introduced in 1990. After going through many workshops and contribution for more than 300 organizations, data mining is described as a process of finding hidden precious data by evaluating the huge quantity of information stored in data warehouses using multiple data mining techniques such as artificial intelligence, machine learning, and of course, statistics. The cross-industry standard process for data mining, or CRISP-DM. Business understanding focuses on understanding the project goals and requirements from a business point of view, then converting this information into a data mining problem, afterward a preliminary plan designed to accomplish the target. Data understanding starts with an original data collection and proceeds with operations to get familiar with the data, to data quality issues, to find better insight in data, or to detect interesting subsets for concealed information hypothesis. Data preparation usually takes more than 90% of the time. It covers all operations to build the final data set from the original raw information. Data preparation is probable to be done several times and not in any prescribed order. In modeling, various modeling methods are selected and applied, and their parameters are measured to optimum values. Some methods give particular requirements on the form of data. Therefore, stepping back to the data preparation phase is necessary. Evaluation refers to the decision on the use of the data mining results should be reached. It evaluates the model efficiently and review the steps executed to build the model and to ensure that the business objectives are properly achieved. The main objective of the evaluation is to determine some significant business issue that has not been regarded adequately. At the last of this phase, a decision of the use of the data mining outcome should be reached. Deployment refers to how the outcomes need to be utilized. Data mining architecture. The significant components of data mining systems are a data source, data mining engine, data warehouse server, the pattern evaluation module, graphical user interface, and knowledge base. So we have here different examples of the data mining architecture. So data mining is a significant method where previously unknown and potentially useful information is extracted from the vast amount of data. The data mining process involves several components, and these components constitute a data mining system architecture. We're going to talk each of these data mining system architecture. So let's talk about first data source. Organizations typically store data in databases or data warehouses. Data warehouses may comprise one or more databases, text files, spreadsheets, or other repositories of data. Sometimes even plain text files or spreadsheets may contain information. Another primary source of data is the World Wide Web or the Internet. Different processes. As the information comes from various sources and in different formats, it can't be used directly for the data mining procedure because the data may not be complete and accurate. So the first data requires to be cleaned and unified. More information than needed will be collected from various data sources, and only the data of interest will have to be selected and passed to the server. These procedures are not as easy as we think. Several methods may be performed on the data as part of the selection, integration, and cleaning. Database or data warehouse server. Hence, the server is cost for retrieving the relevant data that is based on data mining as per user request. Data mining engine. In other words, we can say data mining is the root of our data mining architecture. It comprises instruments and software used to obtain insights and knowledge from data collected from various data sources and stored within the data warehouse. Pattern evaluation module. This segment commonly employs state measures that cooperate with the data mining modules to focus the search toward fascinating patterns. It might utilize a state threshold to filter out discovered patterns. On the other hand, the pattern evaluation module might be coordinated with the mining module, depending on the implementation of the data mining techniques used. For efficient data mining, it is abnormally suggested to push the evaluation of pattern state as much as possible into the mining procedure to confine the search to only fascinating patterns. Graphical user interface. This module helps the user to easily and efficiently use the system without knowing the complexity of the process. This module cooperates with the data mining system when the user specifies a query or a task and displays the results. Knowledge base. The knowledge base may even contain user views and data from user experiences that might be helpful in data mining process. The data mining engine may receive inputs from the knowledge base to make the result more accurate and reliable. The pattern assessment module regularly interacts with the knowledge base to get inputs and also update it. KDD or the knowledge discovery in databases. It is a field of interest to researchers in various fields, including artificial intelligence, machine learning, pattern recognition, databases, statistics, knowledge acquisition for expert systems, and data visualization. The main objective of the KDD process is to extract information from data in the context of large databases. It does this by using data mining algorithms to identify what is deemed knowledge. The KDD process. The knowledge discovery process is iterative and interactive, comprises of 9 steps. The process is iterative at each stage, implying that moving back to the previous action might be required. The process has many imaginative aspects in the sense that one can't present one formula or make a complete scientific categorization for the correct decision for each step and application type. Thus, it is needed to understand the process and the different requirements and possibilities in each stage. The process begins with determining the KDD objectives and ends with the implementation of the discovered knowledge. At that point, the loop is closed and the active data mining starts. Subsequently, changes would need to be made in the application domain. So for example, offering various features to cell phone users in order to reduce churn. This closes the loop and the impacts are then measured on the new data repositories and the KDD process again. So we have here our 9-step KDD process. We're going to discuss one of these KDD processes. Okay, let's talk about building up and understanding of the application domain. The individuals who are in charge of a KDD venture need to understand and characterize the objectives of the end user and the environment in which the knowledge discovery process will occur. So it involves relevant prior knowledge, choosing and creating a data set on which discovery will be performed. This process is important because of data mining learns and discovers from the accessible data. This is the evidence base for building the models. If some significant attributes are missing at that point, then the entire study may be unsuccessful from this respect. The more attributes are considered. On the other hand, to organize, collect, and operate advanced data repositories is expensive, and there is an arrangement with the opportunity for best understanding the phenomena. This arrangement refers to an aspect where the interactive and iterative aspect of the KDD is taking place. This begins with the best available datasets and later expands and observes the impact in terms of knowledge discovery and modeling. Pre-processing and cleansing. It might include complex statistical techniques or use a data mining algorithm in this context. For example, when one suspects that a specific attribute of lacking reliability or has many missing data, at this point, this attribute could turn into the objective of the data mining supervised algorithm. A prediction model for these attributes will be created, and after that, missing data can be predicted. The expansion to which one pays attention to this level relies upon numerous factors. Regardless, studying the aspects is significant and regularly revealing by itself to enterprise data frameworks. Data transformation. This step can be essential for the success of the entire KDD project, and it is typically very project specific. So for example, in medical assessment, the quotient of attributes may often be the most significant factor and not each one by itself. In business, we may need to think about impacts beyond our control as well as efforts and transient issues. So, for example, studying the impact of advertising accumulation. However, if we do not utilize the right transformation at the starting, then we may acquire an amazing effect that insights to us about the transformation required in the next iteration. Thus, the KDD process follows upon itself and prompts an understanding of the transformation required. Prediction and description. There are two significant objectives in data mining. So the first one is a prediction, and the second is the description. Prediction is usually referred to as supervised data mining, while descriptive data mining incorporates the unsupervised and visualization aspects of data mining. Most data mining techniques depend on inductive learning, where a model is built explicitly or implicitly by generating from an adequate number of preparing models. The fundamental assumption of the inductive approach is that the prepared model applies to future cases. The technique also takes into account the level of meta-learning for the specific set of accessible data. Selecting the data mining algorithm. So for example, considering precision versus understandability. The previous is better with neural networks, while the latter is better with decision trees. For each system of meta-learning, there are several possibilities of how it can be succeeded. Meta-learning focuses on clarifying what causes a data mining algorithm to be fruitful or not in a specific issue. Thus, this methodology attempts to understand the situation under which a data mining algorithm is most suitable. Each algorithm has parameters and strategies of learning, such as tenfold cross-validation or another division for training and testing. Utilizing the data mining algorithm. In this stage, we may need to utilize the algorithm several times until a satisfying outcome is obtained. For example, by turning the algorithm's control parameters, such as the minimum number of instances in a single leaf of a decision tree. Evaluation. So here we consider the pre-processing steps as for the impact on the data mining algorithm results. So for example, including a feature in step 4 and repeat from there. This step focuses on the comprehensibility and utility of the induced model. In this step, the identified knowledge is also recorded for further use. The last step is the use and overall feedback and discovery results acquired by data mining. Using the discovered knowledge, the accomplishment of this step decides the effectiveness of the whole KDD process. There are numerous challenges in this step, such as losing the laboratory conditions under which we have worked. So for example, the knowledge was discovered from a certain static depiction. It is usually a set of data, but now the data becomes dynamic. Data structures may change certain quantities that become unavailable, and the data domain might be modified, such an attribute that may have value that was not expected previously.